Welcome back to Learn Yourself. Today we are going to study about Ostwald's process of manufacturing nitric acid. In my previous video we have seen a laboratory method via which we have manufactured nitric acid. Today we are going to study about Ostwald's process. So this is a flow diagram or a diagram via which we are manufacturing a nitric acid. So in this the three-step procedure will be there. The first will be the catalytic tower, in which with the help of catalyst our reaction will go forward. From that whatever products will be there will come to oxidation chamber. Those products will get oxidized. After that those oxidized product will go to absorption tower, from which in the absorption tower from the top the water is falling and all the products will get reacted with water, and at the end we will get our product, that is nitric acid. So let us study it thoroughly. So these are the three-step reactions according to this step 1, step 2 and step 3. So one by one we will study. That first is catalytic tower. In this our reactants are ammonia and air. And what are the ratio for that? Ammonia will be 1 volume and air will be 10 volume. So 1:10 ratio we are maintaining in ammonia and air. These reactants will pass to this catalytic tower and our catalyst is platinum. So our reaction will be, for the first step, our reaction will be when ammonia will react with oxygen. From the air it will react with oxygen with platinum catalyst at the temperature 700 to 800 degrees centigrade, and we will get nitric oxide, NO, and water and some energy will be removed along with this product. So this reaction is exothermic reaction. And the ratio of conversion of ammonia to nitric acid is 95%. So 95% of ammonia will converted into nitric oxide and other will converted into steam and energy. So in first step our products will be, whatever will go to the oxidation chamber will be nitric oxide, that is NO. Now when it will come to this oxidation chamber, here the nitric oxide's oxidation will happen and it will get converted into nitrogen dioxide. When oxygen is attached with any atom, it is, so that atom is being oxidized. So here earlier it was NO and now it is becoming NO2. So oxidation of nitric oxide will happen in the second stage and in the oxidation chamber. So what will be the reaction? So nitric oxide with oxygen at 50 degrees centigrade we will get nitrogen dioxide, and this is oxidation reaction. It is happening in the oxidation chamber, and the first step is exothermic reaction because the lot of heat is generating in the first step. Now in the third step, when the nitrogen dioxide will pass to the absorption tower, from the top the water shower is falling on this gas. So this gas will dissolve in the water and we will get our desired product, that is HNO3 via this reaction. So NO2 will dissolve in water, NO2 will react with water and we will get HNO3 as a product. So the reaction will be nitrogen dioxide will react with water and oxygen and we will get HNO3. This is our desired product. So this is Ostwald's process of manufacturing nitric acid. In first step we have taken two reactants, that is ammonia and air, and the ratio of that is 1:10. With the help of platinum catalyst we will get nitric oxide. That nitric oxide will get oxidized at the second step and we will get nitrogen dioxide. That nitrogen dioxide will further move towards absorption tower, and from that it will react with water and oxygen and we will get HNO3. That is our desired product and it is nitric acid. Now we will study some of the important reasons based on this process. In reasons for Ostwald's process, first is reactants. So what all reactants we are using is ammonia and air. The proportion of ammonia and air is 1:10. So air is, why the amount of proportion of air is so high? Because air is used in all the three steps. From the air we are basically using oxygen. So at the first step, oxygen is required to convert ammonia to nitric oxide. Then from nitric oxide to nitrogen dioxide we need again oxygen. Then from nitrogen dioxide to nitric acid again we need oxygen. And we know that oxygen's percentage is only 21% of air. So we required a lot of amount of air to supply oxygen for each step. First step is conversion of ammonia to nitric oxide. Second step is nitric oxide to nitrogen dioxide, and third and last step is nitrogen dioxide to nitric acid. So that's why we need more air, because we are utilizing only oxygen, and that oxygen we are utilizing in all the three steps, and percentage amount of oxygen is only 20% in the air. That's why we required more ratio of air compared to ammonia. Now second is what will happen in catalytic chamber. So heating is done initially only, afterwards the electrical heating will stop. Why this will happen? Because the first reaction, that is conversion of ammonia to nitric oxide, is exothermic process. So lot of heat is liberated at the end, so that heat only will govern the reaction afterwards. So heating is done initially only, we are heating it electrically. So because of the exothermic reaction, the heating is done initially only. Afterwards, whatever heat is liberating from the reaction will govern the reaction. Now third is oxidation chamber. Now gases leaving the catalytic chamber. This first is our catalytic chamber, then our oxidation tower, then our absorption tower. This is our oxidation tower, this is reaction of absorption tower. So we are talking about oxidation chamber, in which nitric oxide will convert into nitrogen dioxide. So while gas is leaving from catalytic chamber and pass through cooling coils, when they are going from catalytic chamber to oxidation chamber, they should pass from cooling coils. Why this thing is required? Because the temperature of this reaction is around 700 to 800 degrees centigrade. While we require temperature of oxidation tower is only 50 degrees centigrade. So to achieve the temperature of 50 degrees Celsius from 700 to 800 will require the cooling coil. So temperature of catalytic chamber is 800 degrees Celsius and it will require temperature at oxidation chamber is only 50 degrees Celsius. So we require low temperature, and that's why it is required that those gases should pass from cooling coil to achieve lower temperature. Now why we require low temperature? This is important. What is the need of low temperature? So there are two reasons for that. It will make the oxidation of nitric oxide easy. Easily we can convert this at lower temperature. We cannot do so at higher temperature. And minimize the chance of decomposition of nitrogen dioxide. Once nitrogen dioxide will form at higher temperature, again it will decompose due to the high temperature. So we require nitrogen dioxide and it should be in stable condition. So that will happen only at the low temperature. So low temperature is required for two reasons. It will make oxidation easy, and second, it will minimize the chance of decomposition of nitrogen dioxide. That's why these cooling coils are required, and we need lower temperature at second step, while we require high temperature at first step, but heating will done at initial stage only. Afterwards, because this is exothermic reaction, this reaction itself will govern the further reaction. Moving towards our fourth reason, and that is related to absorption tower. So in absorption tower, the steel tower, it is made up of steel. So this steel tower is filled with quartz and water. So first, why the water is there? When water is coming from the top, the gas nitrogen dioxide will dissolve in the water. So this nitrogen dioxide will get converted to our desired product, and that is nitric acid. So that is a function of water. That why we are sprinkling water from the top, because nitrogen dioxide gas will dissolve in water and it will give us nitric acid. Now this is a reaction which we have seen earlier, that nitrogen dioxide will react with water and oxygen and will give us nitric acid. Now what quartz will do? This is important, that what quartz will do, that first is it is acid resistant. So whatever nitric acid will generated here will not affect the quartz. Quartz quality will not get affected by the acid because it is acid resistant. And the second thing is the quartz layer is there in the absorption tower. So what it will do? It will slow down the movement of nitrogen dioxide. Whatever gas is generated, that gas's movement will be slower down by the quartz. So what it will do? This movement, the slower movement, will initiate more and more nitrogen dioxide dissolution in water. So better salvation in water. If nitrogen dioxide gas movement is very fast, then it will not dissolve, it will not get dissolved in the water. But due to the quartz layer, this movement will be restricted, this movement will slow down, and it will give better opportunity to dissolve nitrogen dioxide gas into water. So these two are the function of quartz. That first is acid resistant, and second is it will slow down the movement of nitrogen dioxide gas. So it will easily get absorbed, easily get dissolved in the water. So this is about absorption tower. Now product, which is important for us, that which product we will get, that is nitric acid. So first we will get from this process, we will get only 50% of nitric acid. 50% concentration of nitric acid will be 50%. So this we termed as dilute acid. So from this Ostwald's process we will get dilute nitric acid and not the concentrated one. If we want a concentrated nitric acid, then we have to distill it, and through that we will get 68% concentrated nitric acid. And if we want more concentrated nitric acid, then further we have to distill it with sulfuric acid, and so that we will get 98% of nitric acid, and that we known as fuming nitric acid. So whatever nitric acid we will get from the Ostwald process is dilute one. We will get 50% concentrated nitric acid. But when we will distill it further, we will get 68% concentrated nitric acid, and if you want more concentrated nitric acid, which is known as fuming nitric acid, then further you have to distill with sulfuric acid. Then only we will get 98% concentrated nitric acid. So this is all about Ostwald's process, manufacturing of nitric acid through Ostwald's process, and some important reason. If you have any doubt related to this topic, then comment down below, or you can directly write me at my email address. Don't forget to subscribe Learn Yourself for many more upcoming videos. I'll see you in next video. Till then, keep learning, keep sharing.